Okay. And then, okay, yeah, there you go. Okay, yeah, so what were you saying, Bill, on the, how you were gonna do it?
Okay. So with this, so yes, Austin's method does work, but with Austin's method, you're gonna have to start doing fractions, and fractions sometimes they're not the easiest thing to do, right? So if you look at this question, the diff so you know, you're going from 2, 4 to negative 1, 1. Austin, can you stop drawing?
Sorry, I'm testing it.
Okay. You're going from 2, 4 to negative 1, 1. So in the x direction, you're going negative 3 in the x direction. In the y direction, you're also going negative 3. So if you're going 2/3 of the way from 2, 4 to negative 1, 1, you're going 2/4, you're going 2/3 of negative 3. So you're going negative 2, and then you're also going 2/3 of negative 3 in the y direction. So you're going also negative 2 here. So from 2, 4, if you go negative 2 there, it's 0, and then 4 minus 2, that's 2. So you also get 0, 2.
Yeah, you can also do it like that. Yeah, that's
Okay.
probably better, actually, yeah.
Yeah. So
Okay.
this way, you don't have to work with fractions as much. And fractions tend to take slightly longer, so this way will be preferable.
Yeah. Okay. Number 15. Um, John purchased 3 cassette tapes, regularly priced at $8.88 each. One tape was reduced 12.5%, another 25%, and the other was half off. Find the total cost in dollars of the purchase. So, so you can add all the percentages, right? And just take off all of that on one cassette tape, right? Yeah. Yes. So it's like so like if you took it off of each individual cassette tape, um like so you have one tape equaling 888, and if you reduce that by 12.5%, you're going to multiply that by 1 minus 0.125, right? Or so, but if you just want the reduced amount, the amount that you're taking away from the original, then you just multiply by 0.125, right? So, and if you wanted to find the amount you're taking away when you reduce by 25%, then you just multiply by 0.25, right? And the next one you also multiply by 0.5, right? So these, if you were to, like, what you could do is you find each of these separately, and then you add them all up, and that would be the total amount that you'd be taking off. But you could just add up these percentages first, because they're all multiplying by 888, right? So add up the percentages first, and then you multiply by 888. So that will save you some time. So if you add those up, you'll get 0.875, right? And then so that times 888, this will be the total amount you're taking away from the regular amount. Okay, so your cost would be the regular amount, which is 888 times 3, minus 888 times 0.875. So 0.875 is just 7/8, right? So that'll be 7.77. You're taking off 7.77. And then 888 times 3, that would be 4662. 26.64. And then you take away 777. So that would be 18.81, right? 18.87. Okay, yeah, it is 18.87. So yeah, Bill, do you have anything to add?
So in this case here, all of these numbers, all of the percentages are really, they're 1/8, 1/4, and 1/2. And so they're relatively easy to find. The price of individual cassette tapes because they're all just direct fractions. So the first one is 7.77, the second one is 6.66, and the third one is 4.44. So in this case, because these are so easy to find, you can just for this instance, you can just add them like this because they're really easy to find.
Yeah, that's probably actually better in this case, but I don't know. They're both pretty quick, yeah. Okay, number 16, the base of a triangle is 3 times the length of the altitude. If the area of the triangle is 73.5 centimeters squared, find the altitude in centimeters. Okay, so the area of a triangle is just 1/2 base times height, right? So, and the height is just the altitude, right? So if you say the height of the triangle, okay, yeah. If you say the altitude is x, and you say the base is 3 times that, 3x, and my diagram isn't to scale, but then your area of the triangle would be 1/2 times x times 3x, which is just 3/2 x squared, and this equals 73.5 centimeters squared. So now you can find x. So you multiply by 2, so you'd have 147 over 3 equals x squared. So that would be 4d9 equals x squared. So x equals 7. And that is the altitude, which is what it wants. So 7 centimeters. 99 decreased by 4/5. 99 decreased by 4/5 of 80 is the same as 5/8 of one number. Okay, so let's just write what it says, right? Oh, never mind. Okay, sorry. 99 decreased by 4/5 of 80. Of just means like multiplying. Is the same as 5/8 of what number? So we'll call that x. Now we just have to solve this for x. That will just be, so 80 divided by 5 is 16, and then times 4 is 64. 99 minus 64 is just going to be 35, and that will equal 5/8 of x. And then that is just 7 times 8, 56. 56 is x. Okay. 19, the area of a trapezoid is 144 meters cubed. The length of one base is 14 meters. The altitude is 12 meters. Find the length of the second base in meters. Okay, so we have one base is 14. The altitude is 12. And we want to find the second base. So the area of a trapezoid is just 1/2 times base 1 plus base 2. times the altitude or height, and that equals 144 meters squared. So, and we know base 1 is 14, we know height is 12. Now we just solve for base 2. So 144 divided by 12 is going to be 12, times 2 is going to be 24. And you just minus that by 14 to equal B2, which equals 10. Yep, 10 meters. And if you guys have any questions on like anything we're doing, make sure to ask us. That's the main point of our meetings. Yeah. Okay. So number 20, there are 16 coins in a bank. If all coins are all nickels and dimes and they cost a total of 105, how many nickels are there? All right. So we can set up a system of equations for this. Let's say X is our number of nickels, and let's say Y is our number of dimes. We know we can set up two equations for them, and so we can solve them. So all the coins are nickels or dimes, right? We know there are a total of 16 coins. So that means we know X plus Y is going to equal 16. And they total $1.05. So if we just talk about it in cents, the value of the nickels will be 5 times X, and the value of the dimes will be 10 times Y. And this will equal 105 cents. So now we just solve it. You can multiply this equation by 5. So we have 5x plus, or you can divide that by 5. Or you can do a lot of things, but whatever. And we can minus this equation by that equation. So then we'll have 5y equals 25. And so y will equal 5. Because x plus y equals 16, x equals 11. And what does this ask? How many nickels are there? 11. A student purchased a one-year membership to Health Club for $390. She plans to visit the facility 3 times per week during the first year. To the nearest half dollar, what is the cost per visit? Okay, wait. She plans to visit the facility 3 times per week during the first year. To the nearest half dollar. 3 times per week. Okay. So, okay. So how many weeks are there in a year? 54? Yes? Wait. What? There aren't an integer number of weeks in a year, are there? Wait, Bill?
There is not an integer number. It is 52.
Okay, 52 and plus how many days?
52 plus 1 day, I think.
For 365 days?
Yes. Yes,
Okay,
it's 52
I
plus
guess
1
you
day.
could just say.
So
this is a weird problem, though. I don't know. So I mean, you could just say 3/7 of days, right? And then multiply that by 365. I guess, right?
For this one, you should probably just use 52. I think 52 would be acceptable.
Okay, sure. So let's say there are 52 weeks in the year, and we don't care about the last day. Then the number of times she visits in total is going to be 156. And then, okay, it's to the nearest half dollar. Okay, that's right.
Yes.
So, now we just need to figure out 390 divided by 156 to the nearest half dollar.
Yeah.
Okay, so
So for this, because you're not looking for an exact number, only like to the nearest half dollar, you don't have to actually fully get the answer for this. So if you look at it, two times 156 is 312, right? And if you add one half, if you add one half of it, if you add one half of 156, that you're adding 78. So that gets you really close to 390, and that's the closest you're gonna get with using only half dollars. So it's going to be $2.50.
Yeah. Yeah, just estimate it like that, and it'll be a lot quicker than if you actually try dividing. Okay. What is the largest prime factor of 360? Just prime factorize, I guess, right? So like, just a list, you can just list your factors here and then just like go through it, right? Like, so I can take out a 10, that'll give me 2 and 5. And then I can take out 4, which is just 2s, so that'll be 9. And then 9 is just 3, right? So these are my prime factors, so the largest is 5. Round to the nearest whole number, the square root of 139. So if you look at the perfect squares, so this one is 12, this one is 11. 139 is a lot closer to 144. It's just a 5 difference, and this is a 18 difference, right? So, I mean, you can just say that this will be rounded to 12. If it was closer though, you have to be more careful because the like if you square root something, it's not the same scale as a linear scale, right? Like let's say you had the square root of what? 23, so let's say you had the square root of 132. And this is 12 from, let's say it's 133. This is 12 from 121, and this is 11 from 144. So it would seem that this would round to 11, right? Oh, actually, I'm bad. Let's say this is, okay, yeah, let's use 132. Okay, it seems that this would round. Okay, I'm making a new thing. Okay, we have 144 here. We have 121 here, and then we're gonna have 11 here, and then we're gonna have 12 here. So we're gonna take the square root of 132, and we want to approximate it to the nearest whole number. Oh, actually, this is too close for us to do it. Okay. Let's use bigger squares.
Yeah.
Okay, I don't know. Should I even explain this, or I don't know. Okay, whatever. If we have the square root of 900 and the square root of 861, so this is equal to 30, and this is equal to 29. Now, let's say you had the square root of 8.
Austin is 841.
I'm bad. 841. Let's say you had the square root of 860. No, 870. Okay, let's say you had the square root of 870. No, 871. Yes. 871, I think. So this is 30 away from 841. This is 29 away from 900. So it seems like it would approximate to 29 because it seems like it would approximate to 29 because it's like,
What?
oh, I'm so
It
bad
seems
at
like it should approximate to 30.
Okay,
No,
let's see. Okay, we're gonna use 870.
no, use 871.
No, we just used 871. No, okay. This is 29 away from 841. This is 30 away from 900. It seems like this would approximate to 29, right?
And it does approximate to 29.
Oh my, okay, we're still too close. Okay, I actually this is getting okay. I guess I won't show it, but what I'm trying to say is that the square root scale isn't the same as the linear scale. So you have to be careful. You have to be careful about like if a number seems closer to like under the radicals, it doesn't mean like when you radical it, it would still be closer to that number. I hope that makes sense, but it shouldn't matter much anyway.
So if you're unsure about something, you can. So if you're unsure if it's like in the middle and you're unsure if it's 11 or 12, if you really need to know, you can just find the square of 11.5 and compare it with that. If you're really unsure about it, you can find.
Yeah. So if it was lower than 11.5, it would round to 11, right? And if it was higher than 11.5, then it would round to 12. Yes. If a pair of regular fair dice are rolled, what is the probability that the sum of the dots rolling on the upper faces is a prime number? Okay, so a pair of regular fair dice, so that's going to be the integers from 1 through 12. The prime numbers in this set is going to be 2, 3, 5, 7, 11. And we want to find the probability that that these happened, right? And so what I think of fair dice rolling probabilities is I think of 7 as the most probable, okay? And I think of 7 as 6 chances. And I think of all of it as having 36 possibilities because, you have 6 possibilities per die. And as you move away from 7, you have 1 less possibility for them. So for 6 and 8, they would have 5 possibilities. And for 4 and 9, they have 4 possibilities. And this is pretty easy to remember, so yeah, okay. So, you can just then add the possibilities of all of these. And, oh, not 1, this should be 2. So, and the numbers at the end have a possibility of 1, okay. So, yeah, okay. So 2 has a possibility of 1, 3 has 2 possibilities, I'm bad. And 5 has, this should be 5 and 4. So 5 has 4 possibilities, 7 has 6 possibilities, and 11 has 2 possibilities. And so you add these up, you get 15. So it should be 15 over 36, the total number of possibilities, or 5 over 12. Yes. There we go, 5 over 12. Do you have any other way of doing it though? I mean, I think this way is pretty fast.
Yeah, so basically for this way, this will be the easiest way, obviously. You just have to remember the thing about the fair dice, where
Yeah, just remember 7 is the
6.
most probable.
Yes.
and it has 6 possibilities. As you move away from it, you have 1 less possibility.
Yes. It's one less the one for every number you move away from 7.
Yes. Okay. Number 25, simplify that. I mean, that should be pretty easy. It's just stuff. So 2 divided by 2 squared is going to be 1/2, and you're going to divide by that. You're going to divide 3 by that, and you're going to add 4/3, and you're going to plus 6. Okay. So yeah. So order of operations, you have to do the dividing first. Dividing by 1/2 is multiplying by 2. So you have -6 and you have +6 here, so those cancel. So you have 4/3 on the top, and is that a multiplying dot? Okay. So 3 times 2 is 6, plus 1 is 7. So then you have 4/3 over 7. Now if you have a fraction like a over b, and it's being divided by c, this equals a divided by b times c. So this is going to equal 4 over 21. Did I do something wrong?
You did something wrong, Austin.
Oh man. Okay, that's that's plus. Okay, I thought that was divided.
Oh, that's plus.
Okay.
Sorry about that.
So we have 2 plus 4. Let's start over. We have 2 plus 4, that is 6. We have 3 divided by 6. Yes, 3 divided by 6. Oh, that's so bad. Okay, 3 divided by 6. And that's subtracted. And we have 6 plus 4/3. Okay, 3 divided by 6 is 1/2. We have 4/3 minus 1/2 plus 6. Okay, so why don't we convert all of these into over 6? So we're going to have 36 plus 8 minus 3 over 6. And that is going to be 41 over 6. And this is going to be over 7. So like we said before, if you have a over b, parentheses over c, this is going to equal a over b times c, or 6 times 7, so 41 over 42. Okay. Given 3 to the first 3, and then etc., what is the units digit in 3 to the 25? Oh, okay. So, okay. Yeah, we're gonna end at 9, so that's in like 7 minutes. But so if you look at the units digits of the 3 powers, so we have 3 to the first is 3, 3 squared is 9, and 27, and 81, then 243. You have units digit of 9, 1, 7, 1, 3, and this actually repeats. You can very easily see that it repeats, because if you just focus on the units digit of this one, when you multiply it by 3 to get to the next power of 3, the units digit must be 9, right? Hey, you sure? It must be 9, right? Because the units digit is only affected by the units digit of the number before it, right? Like the 3 times all the stuff after this can't affect that at all. So this must be 9. Now, because we already had this pattern here, we know that it must continue to follow this pattern. So the units digits of 3 follow a 4-cycle pattern of 3, 9, 7, 1. And you can find like where a power of 3 is in the pattern by taking the modulus of the power of 3 that it is. So you're going to take the modulus of 4, okay? So if you have the power of 3 and the modulus of 4 is equal to 1, the unit digit is going to be 3, right? So like right here, oh, what the, okay, yeah. So like right here, we have 3 to the 5th, right? So the modulus of 5 by 4 is 1. So it must have a unit digit of 3, which it does. So why we do modulus is because it repeats or why we do modulus of 4 is because it repeats every like 4 times, right? So if we just associate the remainder of the stuff with these numbers, then we can give it to that unit digit. I don't know, that was a bad explanation, but whatever. So we need to find the unit digit of 3 to the 25th power. We find 25 modulus 4, which is just going to be 1, so that it's just going to be unit digit of 3. Yeah. Okay, expressed in simplest form. A factorial over 5 factorial times 3 factorial. So if you have factorials like dividing over each other, what you usually want to do is you want to clear out the biggest factorial on the bottom with as much of the top factorial as you can. So on the top, you're going to have like 8, 7, 6, 5, ... right? Now 5 factorial is 5, 4, ... right? So this can cancel with the top, this portion of the 8 factorial, right? So we can cancel this part and it'll cancel out the 5 factorial as well. So now we just have 8 times 7 times 6 over 3 factorial. 3 factorial is just 6, right? So we cancel that out with 6. And that will give us, oh, I accidentally skipped the question. I'll go back to it. But that'll give us 56. So the answer to 20 is 56. 27 is evaluate x squared times x minus m if x equals -2 and m equals 3. Okay, you just plug in x and m. So -2 squared is 4. And then you have -2 minus 3, that's -5 times 4 is going to equal -20. Okay. Actually, let's just do these last 2 problems and end the meeting. Okay. So Andre is reading War and Peace as a summer assignment. The book contains 1326 pages. He can read 234 pages in 6 days. If he reads at the same rate, how many days will it take him to read the entire book? Okay. So we have a ratio of 234 pages per 6 days. Yeah, we can divide 6 by that actually. So we can figure out the number of pages he reads in each day. So if we first divide that by 2, that's going to be 117. And then we can divide that by 3 because the digits add up to 9, which is divisible by 3. So if we divide that by 3, we will get 39. So he reads 39 pages per day. And the book has 1326 pages. So now we just need to divide 1326 by 39. Okay, so 39 times 10 is 390, right? If you multiply that by 3, so this will be 30 days. This will give you 72117D. Okay, and then you okay, and then now, so this is 30 days. Now let's add, okay, if we add another 39, that will be 1209. And then if we add another 39, I don't know why I did it like this actually. Okay. So this one is 31. This one is 31. If we add another 39, we will get 8142. 1248. This one is 32. If we add another 39, that will be 718. 2, 1. 1287. And that is 33. This is actually very slow. I probably should have just divided 39 by that.
Yeah, you probably should have.
What?
I said you probably should have just divided.
Yeah. And then you add another 39, which will be 6, 1, 2, 3, 1. Oh, and it actually equals that. So it will take 34 days. But so if it had like, let's say if it was 1327, then you would say 35 days, right? Because in 34 days he can only read 1326, and he needs another entire day to read that last page. Okay, so not 35 but 34. Okay, so yeah, 34 days. Solve for n. Okay, that should be pretty easy. 3n minus 2n is n. Minus n is 0. So we just have 2n equals 4, and n equals 2. Okay, there we go. We solved all of the 1990 chapter sprint problems. Yeah, we'll pick up at the 1990 chapter target problems next time, probably.